Today we're looking at the reteach for 6-1, our properties and attributes of polygons. Remember, polygons just mean straight line segment figures. So we're looking at a polygon. It has sides, just like triangles. Triangles are a type of polygon. The place where the sides meet are the vertex. Plural is vertices. And if a polygon has more than 3 sides, then I can draw a diagonal which connects 2 vertices, which will be inside the polygon, not along the outer edges. So we can name the polygons by the number of the sides. The chart that's on this reteach is very helpful to us so that we know different names for polygons: triangles with 3 sides, quadrilaterals with 4 sides, pentagons, hexagons, heptagons, octagons, nonagons, and decagons are the ones we usually use for those sides 3 through 10. And if it's got more than 10 sides, we just call it an entagon. So if it had 15 sides, I would call it a 15agon. One of the vocabulary words we've used in the past has been a regular polygon. A regular polygon has all the sides congruent and all the angles are congruent, so like an equilateral triangle or a square. A new vocabulary term we're going to talk about today is a polygon convex or concave. Convex, the official definition means all its diagonals are inside. Basically, it's a normal looking polygon. It's concave if it can have a diagonal outside, and the way I remember it's concave if it looks like it's caved in or it's got a dent in it, a cave or a cavity. So if I'm looking at a regular convex polygon, all regular polygons are convex. It's normal looking. Regular means all my sides are the same length, all my angles are the same measure. I have a quadrilateral here, which is not regular. It's called irregular because even though all the sides are the same, some of the angles are acute, some of the angles are obtuse, so all the angles aren't the same. It is convex though, it's normal looking. If I look at this third picture, it's irregular because I've got different side lengths and different angle measures. It's concave because it's dented in here. So it's like having a cavity, concave, caved in. So as I'm looking at my figures and I want to tell whether they are polygons or not and name them. So first I'm trying to see, is it made up of straight line segments? There's no crisscrossing of the lines. So figure number 1, yes, it is a polygon. I need to count the number of sides. 1, 2, 3, 4, 5 sides. It's a 5-sided polygon. I look up in my chart, and that is a pentagon. If I look at the second picture, it is a polygon. It's made up of straight line segments. It's not overlapping. Yes, it's concave. It's got a dent in it, but all the segments are straight line pieces. So yes, it's a pentagon, or not a pentagon, it's a polygon. And I need to count the number of sides it has. I've got 1, 2, 3, 4, 5, 6, 7 sides. And if I have 7 sides, that makes it a heptagon. If I look at the third figure, notice that I have a curved surface here. If it's got a curved surface, it is not a polygon. It is not made up of straight line segments. So it is not a polygon. On the last couple of questions on the side of the page, I want to determine whether the polygons are regular or irregular, and if they're concave or convex. They're all polygons. They're all made up of straight line segments. If I look at question number 4, I notice that I have 2 different side lengths involved. Single tick marks on these 3 sides, double tick marks on those sides. So it's definitely irregular because it's got different lengths of sides. It also has different lengths of angles, so it's irregular. It is a convex polygon because it is normal looking. If I look at figure number 5, all 3 sides are tick marked the same. All 3 angles are tick marked the same. So it is a regular polygon. It is also convex. All regular polygons are convex. And if I look at the last question on the page, I've got a polygon. I've got 2 different side lengths involved, single tick marks, double tick marks. So it is definitely irregular. And notice that it's got a dent in it or a cavity in it. It's concave because of this section here. The official definition of concave means I could connect one vertex to the other and go outside the polygon. So if I drew a diagonal from this vertex to this vertex, I would be outside the polygon. That makes it concave. On the back side of the page, you've got your reference for different polygons. The first column deals with polygons with 3 sides, the different triangles that we've dealt with. Equilateral, isosceles, scalene, right triangles, acute triangles, obtuse triangles. The new polygons that we're going to be looking at, we'll be looking at the polygons that have 4 sides, our different quadrilaterals, and we'll also look at our different regular polygons. So if I look at a square has all sides equal, all the angles are 90 degrees. If I have a regular polygon that's a triangle, it would be equilateral and equiangular. All 3 sides are congruent, all your angles are 60 degrees. If I have another type of quadrilateral, it would be a rectangle where my opposite sides are equal, all my angles are 90 degrees. I could have a rhombus where all my sides are congruent, but I have 2 pairs of parallel lines and my opposite angles are congruent to each other. I could have a parallelogram, and here I've added some additional information for your notes. For a parallelogram, not only the opposite sides equal, and I have 2 sets of parallel lines, but the opposite angles are equal to each other, and the consecutive angles are supplementary. They add up to 180 degrees. If I have a kite, the adjacent sides are equal to each other, and I have 1 set of congruent angles in that kite. I could have a trapezoid where I have 1 pair of parallel sides, so these 2 lines are parallel to each other. We don't usually use the word trapezium, we just call them quadrilaterals. If nothing's parallel, nothing's congruent. It's just a plain old quadrilateral. If you look at the very last column of these notes, you've got some information about some regular polygons. If it's a 3-sided figure, it's an equilateral triangle. 4-sided, a square. All your angles are 90. 5 sides, a pentagon. All of your interior angles are 108 degrees. If you have a regular hexagon, 6 sides, all your interior angles are 120 degrees. If you have a regular octagon, all of your angles are 135 degrees. If you have a regular decagon with 10 sides, all of your interior angles are 144 degrees. So keep this paper handy. You're going to be using it throughout our polygon unit.